Okay, let's talk a little bit about how we would set up the diagram based on the bearing of C from L is 56 degrees. Bearing is measured clockwise from north. So here's L. So from north, 56 degrees means that this line points towards C. And we go in that direction 4.2 kilometers. This is 56. And that means if we draw vertical and horizontal lines at L, this angle right here has to be 34 degrees because we got a 90-degree angle there. And because this line is horizontal, alternate interior angles are congruent when parallel lines are cut by a transversal. Now, looking at the second piece of information, the bearing of C from T is 318. That means we're down here at some point T. If we go clockwise 318 degrees, this line will be pointing at C and we'll be going in that direction 9.6 kilometers. If we rotate to here, that would be 270. And so to get to 318, we need another 48 degrees. So here we've got two horizontal lines cut by this 9.6 transversal. This is 48 degrees. So is this 48 degrees. And that means finally we can calculate the size of this angle right here. Angle LCT is 180 minus 48 plus 34, or 98 degrees. Now, why do we do that? Because eventually I want to find the measure of this red angle right here. And that means I need to find the measure of this angle, subtract 34 to get the measure of this angle, and then finally the bearing will be 56 plus 34 plus that angle right there. Okay. So here we use the law of cosines to get the measure of LT, the distance from L to T, which is about 11. And so to get the measure of angle CLT, we can use the law of cosines. You could also use the law of sines, but here it is with inverse cosine. The law of cosines is inverse cosine of 4.2 squared plus 11 squared minus the opposite side squared over 2 times 4.2 times 11, about 59 degrees. So this angle is 59 degrees. And if you add those together, you get 15 plus, you get about 115 degrees. Here it is a little more accurate. 115.79 degrees. Okay, there you go. Hope that helped. If you have any questions, post a comment.